For our fall 2025 Capstone project, our team created an automated tool imaging system for our sponsor, Seco Tools. For some background, Seco Tools is one of the world's leading manufacturers in cutting tools used across industrial manufacturing. In spring 2025, a Penn State Capstone team built a working prototype of an automated tool imaging system for Seco. It captured images at set positions to monitor tool wear and featured automated positioning, adjustable lighting, and compatibility with tool holders, establishing a strong foundation for a scalable imaging system. Our problem statement was that our follow-up project aimed to build upon the initial prototype by addressing limitations identified during testing and expanding the system's capabilities. The focus was to improve the precision, usability, and adaptability to different tool geometries and imaging requirements. The overall objective of our project was to review, enhance, and refine the previous year's prototype.
We began our design process by reviewing the previous project to understand the strengths and weaknesses of this design. To improve the system strength and stability, we developed new concepts and modeled them in SolidWorks to visualize the assembly and produce 3D printed components. Each iteration was then evaluated, allowing us to refine parts geometry and adjust tolerances to enhance performance.
After a physical prototype was formed, the code for the machine was developed on the Pi used to control the entire machine through Python. This code facilitates the control between UI that the user will interact the tool with and the stepper motors that moves this camera and the cameras themselves taking pictures. The motor and cameras were then tested within the code to get accurate movement measurements and camera focuses as a form of quality assurance on the resulting images captured.
To use the imaging station, first put the 3D printed tool holder into the bottom slot. Second, enter the tool information into the user interface. And then after you've done that, adjust the height of the cameras so that they are at the top of the tool bits. Then hit start and wait for the system to capture all the images of the tool. The user interface will notify the user when it has completed the imaging. Lastly, look over the images within the file database to analyze each image for tool wear and validate the tool geometry. For future improvements to the system, we've thought about implementing artificial intelligence to automatically detect tool wear from the images. Additionally, looking into different lighting settings to optimize the lighting and imaging for each of the tool coatings. And then lastly, just saving the images to a cloud server instead of locally on the computer for easier access to the image by the engineers. Thank you for listening to our project on the automated tool imaging station.